Dilations are our next focus, and we're actually not going to spend too much time here. I'm going to introduce you to the idea, but we're not going to drill hard on it. So a dilation is a transformation that changes the size but not the shape of an object. A scale factor is a number that describes how much a figure is enlarged or reduced, and something called the center of dilation is the fixed point from which a figure is dilated. So, this first image, we have a green pentagon and a red pentagon, and they've given us all the ordered pairs. So the green pentagon has ordered pairs of 0, 0, 3, 3, 6, 3, 6, -3, and 3, -3, while the red pentagon has ordered pairs of 0, 0, 1, 1, 2, 1, 2, -1, and 1, -1. Okay. This is a dilation with point A as the center. The original shape is the green pentagon, A, B, C, D, E. The dilated shape is the red pentagon, A prime, B prime, C prime, D prime, E prime. And that's how those names are said with that little apostrophe on them. That is A prime. So here's how we can tell this. Because A is the center of dilation, A and A prime will have the same ordered pair. That's why they are both 0, 0. The rest of the ordered pairs now will change in the same way. So you will notice that 3, 3 for B became 1, 1. How do we do that? We divide both things by 3. And that holds for the remainder of our points. C was 6, 3. If I divide those both by 3, I get 2, 1, which is C prime. D was at 6, -3. When I divide those both by 3, I get 2, -1, which is D prime. And E was 3, -3. When I divide those both by 3, I get 1, -1. That is E prime. So this is a transformation with A as the center. The next pair of shapes, we have a red triangle ABC. Oh, I want to step back for a second. The scale factor of this original. Because we divided by 3, the scale factor is 1/3. Dividing by 3 is a 1/3 scale factor. On the second shape here, obviously, we have a red triangle ABC and a blue triangle A prime, B prime, C prime. What I don't have written down for me ahead of time are the ordered pairs. That would be really nice to have, so we're going to go ahead and write them down. So A is at 4, 5. B is at 3, 2. And C is at 6, 3. The dilated triangle, A prime, which is way up there, it looks to be at 12, 15. B prime is at 9, 6. And C prime is at, that is 18, 10, I believe. No, sorry, 18, 9. That is at 18, 9. Now, this is not a dilation with one of the points as the center of dilation, because none of the ordered pairs are shared. The alternative to that is a dilation with the origin as the center of dilation. So how does that look different? Instead of there being one ordered pair shared and the rest changing in a certain way, here all of the ordered pairs will change. In order to be a dilation, they need to all change in the same kind of way. So the question is this a constant multiplier? So 4 turns into 12 by multiplying by 3. 5 turns into 15 by multiplying by 3. So a to a prime is times 3. B to b prime. 3 times 3 is 9. 2 times 3 is 6. So b to b prime is times 3. And c to c prime, 6 to 18 is times 3. 3 to 9 is times 3. This is a dilation with the origin as the center. The scale factor is 3. The third shape here, the question is it a dilation? B would be the center of dilation here, since B and B prime share location. Here, we don't have ordered pairs to work from, but we can pretty clearly see these two triangles don't have the same general shape. The blue triangle is much, much shorter on the left side, but only a little bit shorter along the bottom. So this last guy is not a dilation. So to recap, first problem, yes, the origin, I'm sorry, not the origin. A is the center, which means A stayed the same, it was the same ordered pair, and the rest of the ordered pairs changed by the scale factor. The scale factor was 1/3. Second guy, yes, the origin was the center, because all of the ordered pairs changed by the same value. And that scale factor, that value they changed by, was 3. And this last one is not a dilation because the triangles aren't the same. Here we just have an example of being able to dilate. So if we're told dilate by a scale factor of 1.5, all of the sides get multiplied by 1.5 to form their new lengths. That's it. We're not going to be doing much with that. Last example, dilate the figure by the stated scale factor using the origin as the center of dilation. So what's throwing me off here is the fact that the diagram is already complete. So here's what I'm going to do. I'm going to tell you that we had an original shape of ABC. A is at 4, 8. B is at, let's see, that's going to be 3, 2. And C is at 5, 2. And the scale factor will be 2. Because the origin is the center of dilation, that means multiply all the coordinates by the scale factor. So to get A prime, B prime, and C prime, we would multiply everything by 2. So A would move to 8, 16, B would move to 6, 4, and C would move to 5, 2. If, for example, and I'm only going to talk this one through, I said do this but use A as the center of dilation, then A would stay the same, and then we'd have to do some very unique counting to find B and C. You're going to have questions on this, and that's okay. I will help as much as I can. On the quiz, there is not a lot to do with dilation. It is the first page. I keep it as simple as I can.